In this video, I'll show you how to build an AI RAG application in Python and how to get it ready to deploy to production. Now I say that because I myself have made many AI projects on this channel. You've probably seen a few of them. And while those projects are super fun and cool and you can learn a lot, they're not ready to be deployed into the wild and used in a production environment. That's because they're missing observability, logging, retries, throttling, rate limiting, all of the things that you need for a real production grade AI app. And in this video, I'm going to show you exactly how to get all of those things. And the good news is it's free, it's very easy to do, and I'm going to walk you through it step by step using something called Inngest. Now I want to give you a quick demo of what the finished application will look like, then we're going to dive in and we're going to start coding everything out. And to be clear, the stack that we're going to use in this video is going to be Python. That's where we're going to be writing all of our code. We're going to use Streamlit for the front end. We're going to use Quadrant, which is a specific vector database, which you can run locally, which I'm going to talk about when we get to that point. We're going to use Inngest for all of the orchestration and observability. And then we're going to use things like Llama Index for ingesting PDFs. And we'll also use OpenAI for the AI components. I know that sounds like a lot, but don't worry, I will break it down and explain it step by step. Now let's have a quick look at a demo. Okay. So I'm on the computer, and on the left-hand side, you can see a simple user interface that's built in Streamlit. Now, what you can do here is essentially just chat with various PDFs. This represents a very simple RAG application, which is retrieval augmented generation. If you're not familiar with that, essentially what it means is you can upload any file that you want. It will get vectorized, which means turned into a format that essentially can be really quickly searched and kind of pulled in by an LLM. And then we can ask a question. So I can say something like, what does a roadmap engineer do? This is actually in one of the contracts that I uploaded here for my program dev launch, where we're hiring someone to help us build out roadmaps for students, and their position is roadmap engineer. Anyways, we'll wait a second here. It should actually generate the answer for us, and then it will give us that answer based on the document that was uploaded. So you can see it says a roadmap engineer is this, and then it tells us it pulled it from this source. Now in this case, 4 of them were the same sources because there's multiple information from the same source. And then the last one was this invoice 4, which obviously didn't give us any relevant data. Okay, so that's kind of the application we're going to build. But what you may notice is on the right-hand side of my screen, I have this really interesting application open. Now, this is what Inngest looks like. We're running the local development server, and essentially this gives us insights into everything that's happening in our application. So we can view our app. We can see that we have 2 ingest functions here. So we have one for ingesting a PDF, and then for querying the PDF, we can look at them. We can actually manually invoke them directly from here if we want to test them out without a UI. And then we can view all of the runs of these different functions. This is the most useful part in my opinion, because for example, I was testing this earlier and I had a run that failed. Now, the way that I have this set up is that it's going to retry 5 times automatically, and you can see that every retry, it's telling us exactly how long it took to run. We can click into it, we can view the logs and see the error that occurred. I can copy it and kind of dive into that, and then I can actually rerun this particular step and test it again. Then we also have completed runs. So for example, we can see that we had multiple steps in this run right here, where we had to do an embed and search, come up with an LLM answer, and we can see the results at every single step here, so we know exactly what's going on, and we can really have deep observability into our application, which is super important. Same thing with actually loading in a PDF, for example. You can see this whole thing took 3.4 seconds. To load and chunk it only took 74 milliseconds. To actually embed it took a little bit longer, 1.9 seconds. And then finalization, 1.2 seconds, where we returned the result. So that's a quick demo of the application. Don't worry, I'll make it all clear as we go through the tutorial. Now let's hop over to the code editor and start building this project. So before we dive into the code here, I want to explain to you the architecture of this project at a high level and the different components that we're going to use and why we're going to use those. Now to do that, let's start by understanding what RAG is. Now RAG stands for Retrieval Augmented Generation. Essentially, all that means is that rather than relying on the base model or the base training from something like OpenAI or GPT-4 to generate a response for us, we're going to augment that by actually passing in additional data to the prompt This data is typically going to be information from like a PDF document or from our own knowledge store or something along those lines, so that the LLM can reason based on data that's relevant to what we're asking it. So in this case, we're making a PDF RAG application. So that means we'll be able to upload any PDF that we want, and then we can ask questions about any of the information that's inside of those PDFs. What will happen is when we ask that question, we'll search in the vector database for relevant information. We'll then take that relevant information, give it to our model by just actually putting it inside of the prompt, and then we'll tell the model, hey, reason based on this information and give us an answer. So for example, if we had some invoices or something and we ask, how much did I pay Tim? We would go and we would look through all of the invoices, we would take out the relevant information, we would pass it to the LLM, we would say, hey, LLM, use this information and answer the question, and then it would look at that and say, hey, you paid Tim $10, or whatever the amount is. Now, in order to do that, that involves having a vector database and some other components. Now, as I said, kind of the core of what I want to show you in this video is the fact that we can do this at a production level by using an orchestration tool called Inngest. Now, this is very important because when we actually want to go to production, we need to be able to see what's happening. We need to have retries, we need to have throttling, we need to have rate limiting. We just have observability and logging into what's going on with our AI app. Now, I'm thrilled to say that Inngest has sponsored this video. Don't worry, they're completely open source. You do not need to pay for anything. You don't even need to make an account to be able to use this application. And that's exactly what we're going to do in this video. We're just going to use what's called their local dev server. Quickly going through it, you have all different kinds of ways that you can effectively run different steps. And this allows you to orchestrate, which just means kind of manage and organize all of the steps that are happening inside of your AI application. They have a Python SDK, which we're going to be using. They also have a TypeScript and JavaScript SDK, which is a little bit more popular. And you can see that this allows us to actually just have all of the orchestration immediately ready so we could push this into production, see exactly what's happening, have it distributed across multiple servers. It's fault tolerant. We can see everything that's going on, and you'll see how much easier this actually makes development. Okay, that's Inngest, that's the orchestration and the kind of, production ready component. The next thing is we need a vector database. Now, a vector database is just something that's going to store all of our data in a vector format. Now, the way that this effectively works is we're going to convert textual data into this numeric vector, and we'll be able to search these vectors extremely fast for similarity. So what that means, if I type something like color, right, or whatever, some word, that we would be able to turn that into a vector and then compare that vector's similarity to all of the other vectors that we have in our database, which effectively just allows us to really quickly search through all of the documents that we're going to be uploading and find all of the relevant data so we can give it to the LLM. I'm not going to go into this in a ton of depth, but a vector database is just a really fast database specifically useful for use with LLMs that lets us search for similarity. That's typically what we're looking for in kind of documents or pieces of information, so we can pull it out and give it to our LLM. Now, in order to use the vector database, we're also going to use something called llama index. This is going to allow us to actually load in a PDF and then to parse the PDF and essentially turn it into something that we can pass to Quadrant, which is the local vector database that we'll be using. And then the last piece of the puzzle is we're going to be using OpenAI for our LLM, so using something like GPT. We'll also use Streamlit for the front end, but we'll get to that later. Okay, so let's close all of that and let's go into PyCharm, and this is where I'm going to write all of the code. Now, you can use any editor that you want, but I typically do recommend PyCharm because it is just the best for Python-heavy projects. I also do have a long-term partnership with PyCharm, so you guys can check it out. You can get a free trial, see if you like it, of the Pro subscription by clicking the link down below, and you'll see through this video some of the features that it has that really does make it nice for these large projects. Okay, so first things first, I'm just going to go into full screen mode. So let's enter full screen, and I'm going to start setting up my dependencies for my Python project. Now, what I'm going to do is I'm going to type uv init and then dot, and I'm going to just do this inside of a folder that I've opened. So I've opened rag production app, uv init dot, hit enter. It's going to initialize a new UV project for me. All right, now we need a few dependencies here. So what we're going to do is type uv add, and I'm going to start listing them out. Now, first we need fast API. This is because we're going to write effectively an API that's going to be callable to do this kind of PDF ingestion and the querying of the PDF, essentially the RAG application. We're going to bring in ingest. Like I said, this is what we're using for the orchestration. We're We're going to bring in llama dash index and then dash core. We're also going to bring in llama dash index dash, and this is going to be readers dash file. This is going to allow us to read in a PDF. We're going to bring in python dash .env. This is going to allow us to load environment variables. We're going to bring in quadrant. Okay, so let's spell quadrant correctly, dash client. This is going to allow us to connect to a quadrant vector database, which again, we can run locally. Then we're going to bring in uvicorn. This is going to let us run the fast API server. We're going to bring in Streamlit, and we're going to bring in OpenAI. Okay, so these are all of the packages that we need. We're going to go ahead and hit on enter, and then it should install all of those for us. Okay, so that's going to take a second. Now that is done. Perfect. Now what I'm going to do from my application is I'm going to make a new file, and I'm going to call this .env. Now this is where I'm going to put an environment variable for storing my OpenAI API key. That's because we're going to use OpenAI for this project, so let's just get it set up right now. So we're going to type OpenAI underscore API underscore key is equal to, and then I'm going to go back to my browser. I'm going to go to platform.openai.com/API keys. This is where I can get an API key. In order to use this, you will need to have a credit card on file with OpenAI. It should only cost you a few cents to do it with this project, but you also are welcome to use any other LLM that you want, assuming you know how to do that, and I have many videos on my channel that showcase that. So I'm going to go make new secret key. I'm just going to call this rag app and go create secret key. And then I'm going to copy this, and obviously don't share it with anyone. That's not a key that you want to leak. So I'm going to paste that inside of my .env file. I'm now going to close that, and now we are kind of good to continue. So first things first, I'm going to initialize my main.py file. Now inside of main.py, this is where I'm going to write the logic to create an API. Now what I'm going to do is use fast API to make a simple API essentially, and then I'm going to serve some of those API endpoints with Inngest. The way that Inngest works for our orchestration is that any endpoint that we want to essentially have more control over, have observability into, that's typically dealing with some AI component, so not something basic like adding an event to a database, but typically more for the AI operations that could take a long time or require the retries, we can wrap that endpoint in what's called a decorator. It's essentially just a line of Python code. And then Inngest will automatically track everything that happens inside of that endpoint and give us kind of those logs that you saw earlier in the demo that I was showing. So right now it's not going to make a ton of sense because I need to set up a lot of stuff before we can see the benefit of it. But in the meantime, we're going to kind of write out or stub what the API might look like, some of the functions that we're going to have inside of here, and then I'll show you how we connect this to Inngest so while we're building this application, we can debug it a lot easier. Again, I know it's going to be a little bit confusing when we start. It just requires a little bit of code before it can start to become useful, so bear with me here. So we're going to start writing our imports here. We're going to import the logging module. We're going to say from fast API, import fast API like that. We're then going to say import, and this is going to be Inngest. We're then going to import ingest.fast_API. That's because it directly kind of connects with fast API. We're going to say from .env import load.env. And that is almost everything that we need. We're also going to import UUID. This is to create a unique ID. We're going to import OS. We're going to import date time. And we're going to say from ingest.experimental import AI. Okay, and we need to spell experimental correct. And we need to spell experimental correctly. So let's do that. And let's just put all the ingest imports together so they're a little bit more organized. Okay, now we're going to call the load.env function. What this is going to do is load the environment variables inside of this .env file. Now we're also going to start creating some of our clients. So we're going to say app is equal to fast API. And above that, we're going to say the ingest_client is equal to the ingest.ingest like that. Now inside of here, we're going to give this an app ID. I'm going to explain all of this in a second, so bear with me. We're going to call this our RAG application. We're going to say logging is equal to, and this is going to be logging.get, and this is going to be a logger. And for the logger, we're going to get the uvicorn logger because we're going to run this with uvicorn. We're going to say is production is equal to false. This is really important. When we're doing this in development mode, we need to make sure we disable the production, because in production, this is going to require us to have a little bit more security, essentially, to call these ingest functions, which I'll explain later. We're going to have serializer is equal to ingest.pydantic serializer, and that is because ingest supports pydantic typing, and we're going to use some of those type hints and typing system here in this video. If you don't know what that is, essentially this is a really good typing system in Python that allows us to essentially define the types of different variables in this dynamically typed programming language. Okay, now what we're going to do is down here, we're going to serve the ingest endpoint. So we're going to say ingest.fast_API, and then this is going to be .serve. And then what we're going to do is we're going to serve app, and we're going to serve the ingest underscore, oops, if we can type this correctly, client, and then we're going to put a list, and this list is going to include the functions from ingest that we want to serve. So like I was saying, really what we're doing right now is we're just setting up kind of like a normal API using fast API. We could go here and we could say something like, app.get, and we could just define the endpoint here, get notes or something, and just write like a normal standard fast API endpoint. We could run the application with Unicorn like we normally would if you've ever used fast API before. If not, don't worry about it, and it would just work. That's fine. However, when we have kind of AI heavy logic, we want that orchestration on top of it that I was showing you. So if that's the case, then what we're going to do is we're going to create something called an ingest function. Now, when we make an ingest function, because we have this line right here, ingest will automatically kind of serve that function for us, and it will connect to the ingest development server, which I'm going to run for us in a minute and show you what that means. Effectively, what will happen is we'll have this server that now is sitting between our API and our client. So let's say we have some front end, right? Someone wants to use the application. What they'll do is they'll say, okay, I want to upload a new PDF. Rather than directly sending a request to our API here, they're going to send a request to the ingest server. The ingest server is going to take that request and it's going to forward it in the correct format to our API. It's then going to call the ingest function that we're going to write in just 1 second, and it's going to go through that process of logging it, making sure that it's retrying if possible, tracing all of the errors, and giving us all of those benefits. So let's look at a quick example of how we set up one of those functions. So we're going to say @ and then this is going to be ingest underscore client dot create underscore function. Okay. Now, when we make the function, what we're going to do is we're going to say the function ID is equal to, and then we just give this some human readable name. In this case, I'm going to say rag and then ingest, okay, PDF like that. Now, on the next line, we're going to specify the trigger. Now, the way that a function is triggered or called is by some event being issued to the ingest server. Now, that event can be triggered from a client, so something like a front end, or it could be triggered from another function. So like one of our functions could call another function, and we could have kind of this large chain of events that are occurring. So we have an event. An event typically triggers one or more functions to run, and there's all kinds of advanced stuff that you can do with events and kind of with this flow that I'm going to show you. So we're going to say ingest.trigger event like that. For the event, we need to give this a name that we could call from code. So we're going to say rag/ingest underscore PDF. And what I've just said is, okay, whenever this event is sent, or kind of, is triggered, essentially, we're going to run this ingest function. Okay, now that's all that we need for right now inside of this decorator, which is what this thing is called. Beneath here, we need to define the function. It's going to be async. So we're going to say async define rag underscore ingest, and then this is going to be PDF. And then inside of here, we're going to take in some context. Now the type of the context is going to be ingest.context. And what we're going to return for right now is nothing, but we will set the type later. And sorry, this needs to be ingest with 2 n's. Okay, so now that we've done this, we've created this function that's going to be effectively controlled by ingest and the development server, which again, I'm going to run in 1 second. When someone triggers this event, this function will run. We'll get the context of the event, which can be like parameters or data or values that we want to pass here. And then we can start doing whatever it is that we want to do using some of kind of the flow control inside of ingest. So if I want to just make a really simple example, I can literally just do something like return hello world, right? I can just return pretty much anything that I want, so long as it would be valid kind of JSON or a Python object that is, serializable. So I've made this function now, and when you call it, it just returns hello world. But because it's an ingest function, we get the benefit of having the observability, which I'm going to show you now. Okay, so I promise it's going to all start making sense in just 1 second. What we're going to do to start is we're going to run our Python API. So to do that, we're going to type uv run uvicorn, and then this is going to be main:app. Now, the reason why I'm doing that is because the name of our file is main.py, and because the name of our fast API application is app. Okay, so I'm going to do that. I'm going to go ahead and press on run, and it says I got an unexpected keyword here of logging. Okay, so this should not say logging, it should say logger for the ingest client. So let's just quickly fix that and rerun, and hopefully we should be good to go. And there you go, we can see that our API is now running. Okay, so the API is running, which means this function is technically available to be called. However, as I mentioned, what's going to happen is we're going to have something called the ingest server, which is going to essentially control the invocation of this ingest function. So in order to have that server running, well, we need to run it. So what I'm going to do is run a command on my computer. You'll be able to run this as well, that will run this local development server. And this is a huge advantage where this is open source. You can run it locally on your own computer. Of course, you can use their managed solution as well. And if you go into production, you're going to have to deploy some instance of this server. But in this case, locally, it's very easy. So what we're going to do is make sure that we have Node.js installed on our computer. And we're going to type npx and then ingest -client at latest, and then we're going to type dev -u, and we're going to put essentially a link to our API. So if we go here, we can see that our API is running on port 8000. So what we're going to do is we're going to write that. We're going to go http:// and then we're going to go 127.0.0.1, which is effectively localhost. And then this is going to be port 8000/API/ingest. And then we're going to go --no-discovery. Okay, now what this is doing is it's going to run this development server for us, and it's going to tell the development server, hey, I want to connect to an application running on port 8000, and then I put /API/ingest, which is essentially this, okay? So ingest will serve an endpoint at /API/ingest, and that endpoint will kind of control the ingest functions. So I'm going to go ahead and run that. And as soon as I do, it's going to just install that for me. And of course, I spelled it incorrectly. It should not be ingest client. It should be ingest CLI. I don't know why I put client there. Let's fix the command, npx ingest-client. Excuse my dictation tool there. And sorry, not client, -CLI. I keep saying client. Let's just look at it again because I want to make sure you guys know exactly what the command is. npx ingest-CLI at latest dev-u. Nothing else changes other than the fact this is the CLI tool. And you can see that it's now running this, and it tells us that this is running on port 8288. So what we're going to do is we're going to open up our browser here, and we're going to go to localhost port, and then we can copy this 8288. When we do that, you should see something that looks like this being served on your computer. This is the user interface for the ingest development server. And what we're able to do now is if we go to apps, we should be able to sync with this. However, it's telling us there's some error here. This is not synced properly. So let's make sure that our API is running. Okay, and we can see that we're getting a internal server error because we didn't actually put this function that we need to serve inside of this functions list. So excuse me, let's fix that. We're going to go rag ingest PDF. We're just going to put that inside of here and then save. And then what we can do is just shut this down and restart our API. Okay, so now we're actually serving this function. And now if we go back here, let's refresh this, and you can see, let's close this, we can delete this application, that we have this rag app that is showing up as connected, okay, under our apps, and it has one function called rag ingest PDF. We can view the function, so if we go here, we can take a look at it, I can open it up, and if I want to, I can invoke the function just by essentially calling it, right? Or passing this kind of event trigger. From invoke, I can pass any data that I want. In this case, we can just leave it empty, and then I can press invoke function. When I do that, we see that a run now appears under runs. And if I click on this, we can see exactly what happened. So it says it took 35 milliseconds with a 2 millisecond delay. And if we look at this, we can see this was the input, right? So this is the ID, this is the name of the function, this is the data, so this is the function ID, all of this kind of stuff. This is the timestamp. And if we look at the output, we can see that we got hello and then :world. Okay, and then we could rerun this again if we want. Now we have another run that we can look at. We can see all of the information related to it. And this is extremely useful, not just for debugging the application, but for if we actually put this into production. And then if we go to events here, you can see that this event occurred, right? Ingest function finished. And then we also had these functions that were triggered when we invoked a particular function. Okay. All right. So that is kind of a quick example of essentially how we connect Ingest. And now we just leave this development server running. So it's just going to keep running the whole time. And we can keep kind of turning on and off our API as we make changes to it. So what we're going to need to do now, we have this function, we kind of made the connection. We need to start actually implementing the RAG features. All right, so let's move on to our vector database. Now, as I said, we're going to be using Quadrant for this database, and we need to write essentially kind of like a database client that's going to allow us to create the database, load data, search data, etc. So in order to do that, what we need to do is we need to run Quadrant locally on our own computer. Now, in order for this step to work, you will need Docker installed on your machine. I would highly recommend just downloading Docker Desktop. Okay, now what we're gonna do is we're just gonna make a new folder inside of our application here, and we're gonna call this Quadrant_storage, okay? And this is gonna be the volume effectively where we store the vector database that we're gonna use in our application. Now what I'm going to do is copy in a command, and you can pause the video and you can type it out if you want, that's going to allow us to essentially run Quadrant locally on our own computer. Now what I'm doing is I'm saying docker run -d for daemon. The name of the container is going to be Quadrant. You can name this anything that you want. So if we want to go back, we can name it, Quadrant, let's go here, RagDB or something, doesn't matter. We're going to say the port that we're running on is 6333. This is the standard port. And then for the volume that we want to attach here, we're going to print the working directory. This is going to work only if you are on Windows. If you're on Mac or Linux, you're going to have to change this command slightly, which I'll talk about in a second. We're going to go /quadrant storage. This is the, folder that we're currently inside of. So that's why I'm doing that. And then /quadrant/storage, and then I'm saying quadrant, which is the, image that I want to run this container from. Okay, I know it's a little bit confusing. The reason why I have to do this print working directory thing here with the $ is because for some reason in PowerShell, this messes up a little bit and doesn't work locally. For you, you should be able to just replace this with a // which references the local directory. Worst case, you can put the full path to where you want to have this storage, and it doesn't need to be in the same directory as the application. So it's completely up to you. If you're on Windows, again, go with this. Okay, so $ and then pwd, and sorry, I think this needs to be inside parentheses, not braces. If you're on Mac or Linux, go with // and then again, make sure you have this Quadrant storage created in this directory that you're referencing. Okay, so we're gonna go ahead and run this. You shouldn't really see any output. You should just get some random string that kind of looks like a hash here, and then it should just be done. Now in the background, if you open up Docker Desktop, you should see that there is now a new container that is running. So let's wait for this to load for a second. Okay, and you can see, sorry, it just loaded. We have Quadrant RagDB, it's running. We have the container ID, we have the image, we have the ports, and we can control that from here. Okay, and I'm just gonna shut down this other container that I don't know why that's running because I don't need this active. So let's just delete that. Okay. Anyways, there we go. Now we have Quadrant running and we're able to connect to it from our code. So what we're going to do is we're going to make a new file here, and we're just going to call this vector_db.py. Okay, we can add that to Git, that's fine. And inside of here, we're going to write the code that will allow us to connect to our Quadrant database and to search something in the database. So what we're going to do is we're going to say from Quadrant, okay, if we can spell this correctly, _client, we're going to import the Quadrant client. We're then going to say from the Quadrant client dot models, we're going to import the vector params, the distance, and the point structure. Okay, and we're going to make a class. Now for the class, we're going to call this just Quadrant storage. We're going to do an initialization. So we're going to say define init. We're going to take in self. We're going to take in some URL. And by default, the URL is going to be http://localhost:6333. Then we're going to take in a collection. So for the collection, I'm going to call this documents. This is going to be the collection where we're storing the information essentially. And we're going to take in the dimensions or dim, and this is going to be equal to 3072. Okay, now there's a lot of stuff to explain when it comes to vector databases. Essentially with this quadrant database that we're using, it's very high performance and we can run it locally. However, realistically in production, you would actually deploy this database out and then you would probably end up changing this URL. So you're connecting to the deployed instance, or you're using Quadrant's kind of managed service, right? I don't really know exactly how that works, but they obviously have their own, thing that they'll try to sell you. So here we can go self.client is equal to, and then we're going to bring in the Quadrant client. We're going to pass the URL equal to URL, and we're going to say the timeout is equal to 30 seconds, so that if we don't connect in 30 seconds, then we essentially crash this program. We're going to say self.collection is equal to collection, so we store that as a variable. And then what we're going to do is we're going to create a new collection in our vector database inside of this Quadrant storage folder. You can see now we have this collections folder, right? We have these aliases, a few other pieces of data. So what we're going to do is say, all right, do we already have a collection called docs? If we don't create one, if we don't create one, if we do, then we don't need to create one. So we're going to say if not, and it's going to be self.client dot, and this is going to be collection underscore exists. And you can see the autocomplete coming here from PyCharm. We're going to put in the name self.collection. Then what we're going to do is say self.client.create collection. And for the collection, we're going to say the collection name is equal to self.collection. And we're going to say the vector, and this is going to be underscore config, is equal to the vector params. The size of our vector is going to be the dimensions. And we're going to say the distance is equal to distance.cosine. This is the algorithm or formula or whatever you want to call it for calculating the distance between different points in our vector database. Again, without getting into any advanced linear algebra here, which is kind of the foundation of how vector databases work, what we're going to have is a certain number of dimensions. This is effectively kind of the number of values that we have inside of our vector. And we're going to kind of turn these text documents into vectors. We're then going to compare these vectors against each other using this distance formula, and vectors that are closer to each other in this vector space have kind of similarity. At least that's what we're hoping for. So we'll be able to really quickly find those vectors that are close to us, pull them out of the database, get their original text data, and pass that to our LLM. So that's what we're setting up here with this initialization. Now we're going to make a function here called upsert. This just means essentially insert and update. And we're going to say self IDs, vectors, and payloads. And what we're going to do is say points is equal, and then we're going to have a new, list comprehension here. And we're going to say this is point struct. And then this is going to be ID equals IDs I, vector equals vector, and then I, or vectors I, sorry. And then we're going to have payload is equal to payloads I for I in range. And then this is going to be the len of IDs. Now what this is going to do is it's going to get all of the associated IDs, vectors, and the payloads from these three lists effectively and create a point structure, which is what we need to create in order to insert this into our vector database. And then we're going to insert it. So we're going to say self.client.upsert. Okay, we're going to upsert the, self.collection. So let's type this correctly, self.collection. And then we're going to say points is equal to points. Okay, so the idea here is that we're going to pass a series of IDs, which is a list, a bunch of vectors, which is kind of the vectorized version that's going to be in a dimension of 3072. And then payloads, and payloads is going to be real data that's actually human readable, that kind of represents the information that we've vectorized. We're going to convert all those three things into this point structure, which is just what's required for Quadrant and the way that we're doing this. And we're going to insert that into the vector database. Okay, so that allows us to now add vectors effectively. And the more important thing is searching for vectors. So we're going to say define search. We're going to say self. We're going to say query underscore vector, like that. And we're going to say top k. This is going to be an int, and by default, it will be equal to 5. Now we're going to say results is equal to self.client.search, and we're going to search the collection underscore name equal to self.collection. We're going to say the query vector is the query vector. We're going to say with payload is true. And we're going to say the limit is equal to top underscore k. Now, top k just means that we're looking for this many results from the vector database. So we're going to look for 5 results in this case. We could look for 2, we could look for 10, we could look for 20. Obviously, the more you look for, the longer this could potentially take, but it's still very, very fast. Okay. Then we're going to say context is equal to an empty list, and sources is equal to an empty list. So the reason we have these variables is because I need to get all of the context or information. I want to store that in one list, and then I want to get all of the sources, so the documents essentially that we pulled this information from. So I'm going to say for r in results, I'm going to say payload is equal to get attribute or get attr. This is going to be r payload or none. And then or we're going to have this empty dictionary. We're going to say text is equal to payload.get, and we're going to get text, or we're going to get an empty string. And we're going to say source is equal to payload.get, and we're going to say source or an empty string. Okay. Now what we're going to do here is we're going to say if text. Okay. So if there is text, we're going to say context.append text and sources.append source. And actually, this just reminds me, I'm going to just convert the sources into a set because I don't want to keep adding the same source over and over again. So we're going to say context is .add, and then rather than append, we're going to say .add source. And then what we're going to do down here is we're going to return, and we're going to say context, and we're going to return the context, and then the sources we're going to convert to a list, and we're going to return the sources. So what this is going to do is it's going to search our vector database. It's going to get the relevant results based on this query vector, which again, we'll look at in a little bit. And then we're going to pull out all of the sources and the context and return that. Okay. So that's that for the vector database. Now, one thing to note, the way that I've done this is that we are going to lose which context is associated with which source. So if we wanted to, we could change it back and then we would have kind of the related data based on the indices. In this case, I think it's fine just to have it as a set. So that's our vector database. The next thing that we need to do is have a way to essentially read in a PDF. So I'm going to make a new file, and this new file is going to be called data_loader.py. Now, this is where I'm going to use llama index to load in PDF documents and to embed them. Because what we just did is we made the vector database, which will allow us to upload essentially vectors and search for vectors. But the thing is, I still need to create the vectors. So let's do that now. So I'm going to say from OpenAI, import OpenAI. I'm going to say from llama index dot readers, okay, dot file, import the PDF and then reader. I'm going to say from llama index dot core dot node parser, okay, import the sentence splitter. And then I'm going to say from .env import load.env. Now I'm going to call the load.env function again in here, and I'm going to initialize an OpenAI client. So I'm going to say client is equal to OpenAI. Now, because we've defined this variable, OpenAI API key, inside of this file, we don't need to actually pass anything else to, what is it here, this client. It will just automatically find and look for that variable, and because it exists, it will essentially allow us to use OpenAI. Now, let me briefly discuss what we're about to do here. So we're going to effectively load in a PDF. Now, when we load in a PDF, that could be very large. It might be, 1,000 pages long. We can't just embed the entire PDF. And by the way, embed means just effectively convert it to a vector so we can store it in the database. Instead, what we need to do is chunk it. Chunk it means we need to break it down into smaller pieces and then embed those smaller pieces. And the size of the pieces is relevant here. We don't want anything that's too big, but we don't want anything that's too small, so that we still have a lot of really relevant data, but we don't have, massive amounts of data or really tiny pieces of data that are going to be hard to search for. So what I'm doing here is I'm going to use llama index to read in our PDF and then to split all of the sentences in that PDF into chunks. We're then going to take those chunks, we're going to embed them, and then we're going to store that in the vector database. So what we're going to say is our embed underscore model is equal to the text embedding, and not this one. It's going to be -3 large. There's all kinds of models that can embed text for you. In this case, we're using OpenAI's. This is a pretty popular one. and we're going to say the embed underscore dimension is equal to 3072, and we need to make sure that matches what we have inside of our vector database, which is 3072. Okay, this is effectively how large the vector is for the text that we're embedding. Then we're going to say our splitter is equal to the sentence splitter. We're going to have a chunk size. I'm going to say chunk size is 1000, and the chunk overlap. Now, the chunk overlap is how much of the end of one chunk is included in the beginning of another chunk. The reason why you would have an overlap is because if you have a sentence like, hello world, my name is Tim, let's say we want to split this, right, into two chunks. Well, we might have one chunk that is hello world, we might have one where his name is Tim. Now, what we would do if we had an overlap of, let's say, 1 or something, and 1 represented a word, is in the first chunk we would have hello my, and then in the second one we would have my name is Tim, where we would kind of duplicate the word at the end in the beginning of this chunk so we don't potentially lose a lot of relevant context. So in my case, I'm going to go with a chunk overlap of 200. This represents characters, by the way, not words, so that we're able to kind of split it properly. Okay, now anyways, hopefully that makes sense in terms of how that's going to split, but it's just going to do essentially sentence splitting for us and create all of these chunks. We're then going to say define load and underscore chunk underscore PDF. We're just going to take in a path to the PDF, which will be of type string. Now we're going to say our documents are equal to the PDF reader dot load data, and we're going to say the file is equal to the path. This is just going to look for the PDF and it's going to load it. We're then going to say text is equal to, and we're just going to pull out the text. We're not looking at images or anything. And we're going to say d.text for D, which stands for, kind of data or document, for D in docs, if get attr d text none. So what this is going to essentially say is, okay, we're going to get all of the text content for every single document inside our documents, all right, if this document has some text attribute, because we might have a PDF that only has images, for example, not text. We're then going to say chunks is equal to this. We're going to say for T in text, and we're going to say chunks dot extend, and then we're going to say splitter, okay, dot split text, and we're going to split this with T, and then we're going to return our chunks. Okay, so this is the chunking process. Again, I don't want to break it down too much further than that. Effectively, we're taking the PDF, turning it into smaller pieces of textual data, and then we're going to embed each of those pieces of data. So the next function we're going to have is embed underscore text. This is going to take in our text, which is going to be a list of type string. This is then going to return, I'll just type it manually here, a list of type float, which is effectively what our vectors are going to look like. We're going to say response is equal to client.embeddings.create. We're going to pass the model, which is the embed model, and we're going to say the inputs is equal to text. We're then going to return item.embedding for item in response.data. Okay. So what this is going to do is it's going to send a request to OpenAI. It's going to pass all of the text, which is all of the text that we've kind of chunked here already. It's going to embed them, which means convert it into a vector, which we can store in the vector database. We're then going to go through the result here, so response.data, and we're just going to pull out the embedding itself. We don't care about any of the other metadata that's going to be included. So that's our data loader. That's our vector database. And now we're going to move over to main.py. Okay, now I want to be able to test the ingestion of a PDF first. So I'm going to write this function by using some of the functions that we just wrote here. And then we'll kind of continue, and there's a bit more advanced stuff that we want to get into. All right, so let's start by importing some of the stuff that we just wrote. So we're going to say from data loader, import the load and chunk PDF, and import the embed text. We're then going to say from the vector underscore database, import, okay, the quadrant storage like that. Now quickly, I'm also just going to make a new file here. I forgot to do this, where I'm going to create some custom Python types. So I'm going to call this custom types.py. The reason for this is that I want to have these types so that I can make my application a little bit more readable, and I can import and use Pydantic, which is supported in Inngest. So I'm going to say import Pydantic, and I'm just going to write some really simple Python classes that represent some types that I'm going to use in my app. So I'm going to say class, and I'm going to say rag, chunk, and src, and this is going to be Pydantic dot base model. And then what I'm going to do is say chunks, and this is going to be a list of type string. And I'm going to say the source ID string is equal to none. Now what this type is going to represent is essentially the result after we chunk and get the source for a particular PDF document. I'm then going to say class, and this is going to be rag, if we can spell this correctly, upsert result. This is going to be the result after we upsert a document. So we're going to say pydantic dot base model, and then we're just going to say ingested, and this is going to be an int, just representing how many, things that we ingested. We're then going to say class, and this is going to be rag search result. So you can guess what this one is when we're searching for some text. That's what we're going to have here. We're going to have pydantic dot base model, and then we're going to have the context, which is going to be a list of type string, and we're going to have the sources, which is going to be, if we type this correctly, a list of type string. Then we're going to have one more. This is going to be class rag query result. So this is different than the search result. This is the query that the user is actually sending, to the endpoint. So we're going to say pydantic.baseModel. We're going to say the answer is of type string. We're going to say the sources is list of string. And we're going to say the number of contexts is an int. Okay, so I think that's all we need for our custom types. Let's go back to main. Let's now import these custom types, and then we can use them in this first function. We'll test it, and then we'll move on to the next one. So we're going to say actually from custom types import, and then we need to import all of these. So what did we have? We had the rag query result, we had the rag search result, we had the rag upsert result, and we had the rag chunk and source. Okay, so now let's go into this function that we wrote, and let's start setting it up to actually utilize ingest properly and to kind of perform the steps that we need. So first things first, what I'm going to do is kind of explain to you a little bit about how this works when we actually run an ingest function. So as you saw, we kind of have a diagram that looks like this, right? We have ingest, which is kind of the execution engine or the local server. We send a request to there. That then sends a request to our API endpoint. The API endpoint then goes to our ingest function, and then inside of the function, we can have these things called steps. Now, each step is kind of an individual operation that we're going to track, that we could retry if needed, and that we're going to kind of observe, right, and get all of the logging and the information for. So if I just go quickly over to overview here, you can see, right, that there's kind of three main things in ingest. We have the triggers, which we've already kind of talked about, where it's essentially events that can trigger something to run, right? It could be a webhook, could be a cron schedule, could be a manual trigger, like in our case. We have flow control, which we're not really getting into right now, but we will talk about the concurrency, the throttling, and all of that later on. And then we have steps. And steps are kind of how we convert a function into a workflow with multiple retryable checkpoints. So if you look at an example right here, we have this step, right? We're saying, okay, we're going to run step one, which is getting data. We're going to wait for that step to finish, and then we're going to save the data. Now, by wrapping these different operations in these steps from ingest, this allows us, again, to have all of those advantages of the step where we can retry it, we can wait for a step to finish, and we can see kind of what the application's actually doing at each step. So we have kind of deep observability into our functions. So I'm going to show you how you make a step, but if we go here, you can see running retryable blocks, pausing execution, pause for an amount of time or wait for a specified amount of time. There's a crazy amount of stuff that you can do with the steps here, but what we're going to do is have two steps in our function. The first step is going to be for loading the PDF, and then the second step is going to be for embedding it and kind of chunking it, or not chunking it, but adding it to the vector database. So what I'm going to do is I'm going to write two internal functions. The first function is going to be load. Now this is going to take in a ingest dot context, and it's going to return a rag, chunk, and src result. Okay, and for now we're just going to go with pass. We're going to have another function, and I'm going to call this upsert. Now this is going to take in chunks and underscore src. This is going to be of type rag, chunk, and src, and it is going to return a rag upsert result. For now, again, we are going to pass. So the idea is I have these two individual steps that I want to run inside of this function. We need to load, and then we need to add to the vector database. And we can make as many steps as we want. In this case, it's kind of the logical thing to do. We could even make more steps if we want, And if we did that, then we would have obviously an even more detailed function where we go through everything. We can see the timing, all of that kind of stuff. So what I'm going to do down here is I'm going to say chunks and underscore src is equal to, and rather than just calling the load function directly, which is what you would do if you're just working kind of standardly in Python, is we're going to wrap this in a step. Now, the way we do that is we say await, and then this is going to be ctx.step.run, and then we put the name of the step. So in this case, we can just call this anything human readable that we want. So I'm going to say load and chunk, and then we put the function that we want to call. Now, because we want to call these functions with arguments, what we're going to do is put a lambda, and we're going to say lambda, and then this is going to be underscore load, and then we're just going to pass ctx, which is this value essentially here, right, into this load function. Now, we don't really need to pass it like this because we could just use this as a global variable inside of the function, but for now, that's how I'm going to do it. Now, we also have the ability here to specify the output type. So I can say the output type is rag, chunk, and src, because like I said, this now supports Pydantic. All right, now we're going to do the exact same thing for the next step. So what we're going to do is we're going to say ingested is equal to await ctx.step.run. This step is going to be called embed and upsert. And keep in mind, like, you can name these steps anything that you want. It's more for the logging to see it. We're going to say lambda, and then this is going to be underscore upsert. And then we're going to pass the result from the previous step, chunks and src, and we're going to put the output type equal to the rag and what is this, upsert result. Okay, so this is how we call the steps, right? And then what we could do is we could say return ingested dot, and I'm going to go model underscore dump. What this does is it just takes our Pydantic model and converts it into JSON or a Python object, so kind of Python dictionary, sorry, and allows us to return that because these functions need to return something that is what's known as serializable. So we just model dump the, Pydantic object, and we're good to go from there. So that's kind of how we set up the steps, right? We're saying, okay, we're going to run this step, we're going to wait for it to finish, then we're going to run this step. Now, you could run these steps in parallel, right? You could run them at the exact same time. You don't need to wait for one to finish because we're doing these asynchronously. So we could just remove the await, right? And we could just run them kind of one by one. So we could just remove the await. We could run them at the exact same time. We could run it in parallel. Like, we can control the flow however we want. But in this case, I do want to wait for them to finish running because they will take, a second, and I need the result from this one before I can do the result here, or before I can execute this. So let's write the context of the functions now. So I'm going to say inside of load, what we need to do is get our PDF path. So I'm going to say ctx.event.data, and then I'm going to get the PDF path. I'm then going to say the source underscore ID is equal to ctx.event.data.get, and I'm going to say source underscore ID, and then I'm going to put PDF path here. Now, this is because if I pass a source ID myself, then I will use that. If not, then we'll just use the PDF path as the source ID. We're going to say chunks is equal to load and chunk PDF. We're going to take the PDF path, and what we're going to do is return rag, chunk, and src. And we're going to say the chunks is equal to the chunks, and the source ID is equal to the source ID. Okay. So that is loading. What we're doing, right, is we're just going to load and chunk the PDF, and we're effectively going to return that result. Now, upserting, we're going to say chunks is equal to chunks and src.chunks, right? The typing is nice here. We know what we're going to be getting from this object. We then are going to say the source ID is equal to chunks and src.source ID. We're going to say the vectors is equal to, and this is going to be the embed text. From the embed text, we're going to take in the chunks. And by the way, if we wanted to, like, we could convert this into a step. It's not necessary because it's already kind of a part of this, and this is the long running operation anyways, but we can have, other steps from one of these steps. We can also trigger another function from this ingest function, and we can make it, as complex as we want. So I'm going to embed that. I'm then going to say IDs because I need to generate a unique ID for all of these vectors. And I'm going to say this is string. And then we're going to say uuid.uuid4. This is going to create a unique identifier for us. And sorry, actually uuid5, not 4. We're going to take uuid.namespace, and we're going to use namespace URL. Don't worry too much about exactly what this is. Just bear with me because this will identify or make a unique ID. We're going to say source underscore ID, and this is going to be associated with I, and then we're going to go for I in range len of, yes, len of vex, like that. Or actually, rather than going vex, let's just go len of chunks, although it shouldn't really make a difference. Now that's the IDs. The next thing that we need is the payloads, because we've generated the vector, but I need the ID for every vector. I need the payload for every vector. So I'm going to say payload is equal to, and then this is going to be source. The source is going to be the source ID, so we know where it came from. We're going to say the text is equal to chunk at I. And then, sorry, this is chunks, not chunk. So it's going to chunks I for I in range the len of chunks. So again, what we're doing is we're kind of looping through all of the chunks, and we're getting, all of the text and the source ID for that, so we can have that as a payload. So we have an ID, we have a payload, we have the vectors. Now we're able to actually pass this to the quadrant store so that we can store it there. So we're going to say quadrant storage. Okay, we're just going to initialize it. We're going to say .upsert, and then we're going to pass our IDs, our vectors, and our payloads, and we're going to return the rag upsert result. And for this, we're going to say ingested is equal to the length of, and then this is going to be, what did we have here? Chunks. Okay, so the number of chunks that we actually ended up ingesting. All right, so that's actually it for this function. You know, in theory, assuming I didn't make any mistakes, which is unlikely, this will run, and we will be able to actually see the result running inside of Inngest, and we'll be able to upsert this into the quadrant database. So right now, let's look at what we have. We have the Inngest server running. Our server is currently running, but we need to stop it and restart it because we made a change here and it's not in kind of debug mode right now or reload mode. It's going to take a second to load up here because it's connecting to the database. Okay, we can see that it's all good. What we're going to do now is we're going to go back to our development server. Now we're going to go apps. We're just going to make sure it's connected. Looks like it is. Let's go to our functions. Let's view that. And I actually want to test invoking this. So in order to invoke this, I'm going to press on invoke. And for my data, I'm going to pass my PDF path. And I need to pass a valid PDF path. So what I'm going to do is I'm going to go and get the absolute path to a PDF from my documents, and I'm just going to paste it inside of here. Let me do that now. Okay, so I just have a path here. I had to escape the slashes because it's not going to allow me to do this in the string due to how the slashes are, how they escape the string essentially. Now this is just a link to one of the resources that we actually have for dev launch where we have kind of like a DSA roadmap. And anyways, what I'll do is just go and press invoke function. When I do that, we see a new run is triggered. Now it looks like it's just waiting for this to run. So it says running. And then I guess there was an error, state finished. Okay, I don't know what that means. File not found error. Okay, so you can see we had a file not found error. So clearly I kind of made a mistake there. It's going to keep attempting this a few times based on how the default settings are set up. So what I can do is just cancel that for now. And that's the whole point of having this, right? We could debug this. I'm going to go to functions, go back here, go to invoke, and I'm now just going to put a new file. And it looks like actually it wasn't 2 graphs, it was 12 graphs. I'm just looking in my file explorer. So let's try it now. We have this new run. We can see a load and chunk look to work pretty fast, 48 milliseconds. We get 2 chunks here because of how much content was in this document. And then we have embed and upsert, and we can see that we ingested 2 documents. And that took a little bit longer to go in the vector database, whereas loading and chunking was very fast, right? Where the embedding, required us to call out to OpenAI, so it takes a second to get the result. And then we have finalization down here. Cool. So that's also just a really nice way to test this, right, from this UI rather than having to make the front end. So what I'm going to do now is going to move on to the next function, which is going to allow us to actually query our PDFs, right? So let's make another ingest function. So here we're going to say at ingest, and then this is going to be underscore client dot create underscore function. For the function, we're going to give this an ID. So we're going to say function underscore ID is equal to, and this is going to be rag, and then we'll go here, query PDF. Okay, that can be the name. Then we're going to say the trigger is equal to ingest.trigger event. For the trigger, we'll go rag query underscore PDF underscore AI because we're using AI to do this. We could do it without AI as well. We're then going to say async define rag underscore query underscore PDF underscore AI. We're going to take in our context, which is the ingest dot context like that. And what we're going to do now is start setting up essentially everything that we need to do to query the PDF. Now, the first thing that we're going to do is have a function. Okay, I'm going to call this search. Now for search, we're going to take in a question, which is a string, and we're going to take in the top underscore k, which by default will be equal to 5, and which will be an int. Okay. Now inside of here, we're going to say our query vector is equal to embed underscore text, and we're going to pass a list with our question, and then we're going to pull out index 0. The reason for this is that if I want to query my database, I need to do it with a vector. So whatever the question is that the user asked, I need to embed that so it's in the same format as everything in the vector database. Because this normally takes in a long list of text, we're just going to pass it as a list and then take out the first result. So we'll have this as our query vector. Then what we're going to do is we're going to say our store is equal to quadrant storage. And we're going to say found is equal to store.search. We're going to pass our query vector, and we're going to pass our top k. We don't need to pass it as the keyword parameter or name parameter or whatever you want to call it. And we're going to say found is equal to store.search, and we're going to search based on that query vector. We're then going to return our rag, and this is going to be search result. And we're going to say context is found and then context, and sources is found and then sources. And we can also just add the return value here, which is the rag search result. Okay, now if we go down here, we've kind of built out the first step, but there is more that we need to do. So first thing, we're going to get the question from our event data. So we're going to say ctx.event.data, and we're going to pull out what the question is. We're also going to pull out the top k because this is something that will allow the user to pass. So we're going to say ctx.event.data.get top k and then 5. And we're also just going to convert this to an int in case they pass it as a string. Okay, now we're going to say found is equal to, and we're going to await ctx.step.run. We're going to run the step, which we're going to call embed and search. And same thing as before, we're going to call this function. So we're going to say lambda underscore search. And we're going to pass the question and the top k. And we're going to say that the output type, so let's specify that, is equal to the rag search result. Okay, and I don't know why it's giving me that. I didn't want that autocomplete. All right, so we have the output type, rag search result. Let's make this left side a little bit smaller. And we're running this now as a step. So again, it will be retriable and we'll have all of those benefits. Now I'm just going to copy in the prompt that I'm going to use for the LLM because now once we find the information, we need to pass this in a prompt. So what I'm going to do is say content block, and I'm going to join all of the context. So all of the sentences essentially that I found like this, where I have a dash and then I have the, sentence, 4C in contexts, and I'm going to combine them with kind of 2 new line characters. I know this looks a little bit weird, but I'm just taking all of the context in a list and converting it into a string. And then what I'm going to say is the user content. So this is essentially what I want to ask, or kind of like the prompt is going to be use the following context to answer the question. Here's the context, then here's the question. Answer concisely using the context above. Okay, that's the prompt that I want. Now what I'm going to do is I'm going to use an adapter here from Inngest to actually call the AI model. So I'm going to say adapter is equal to ai.openai.adapter. Now for the adapter, I need to pass my authorization key. This is going to be os.getEnv OpenAI API key. I need to manually pass it here because we're not using the OpenAI client now. We're using the adapter from Inngest. I'm going to say the model is equal to, and then I'm going to pass GPT-40-mini. I'm just going to use a small one because I don't want it to be super expensive. And then I'm going to generate a response. Now, by using this AI adapter and generating a response here with the method you're going to see in a second, again, we get the same benefits like we do with the step function, where it will automatically be retried. It will handle the throttling. It will handle the rate limiting. As you probably know, when you call these LLM providers, there can be a lot of errors that pop up. So we're going to say response, or res, is equal to await ctx.step.ai.infer. So this is an AI inference. It has a special kind of syntax here inside of Inngest. We're going to call this the LLM answer. So again, it will be observable to us. We're going to pass the adapter, which is equal to the adapter that we just wrote. We're going to pass the body, and for the body, this needs to be equal to, we're going to pass max tokens equal to 1024. We're going to pass the temperature equal to 0.2. This is essentially how random the model is going to be. So we want to be pretty low on temperature. Now I'm spelling temperature completely incorrectly, so let's fix that spelling. And then we're going to have a message. So we're going to say messages actually is a list. And for the messages, the first thing that we're going to do is we're going to say role, and this is system. And then the content, let's fix this typing here, is going to be equal to kind of a system message, and I'm just going to paste in a simple one here. You can make this as detailed as you want. I'm going to say you answer questions using only the provided context to make sure that it really is not kind of going crazy and it's just using what we provided. And then I'm going to say role, user, and then content, and then I'm going to pass to this, again, if we fix the typing, the, what did we call this up here? The user content. Okay. So that is going to now generate the response for us. Now, after the response, we need to get the answer. So we're going to say answer is equal to res. This is the default format from OpenAI. So we're going to say choices, 0, message, and then content, okay, because you can pass multiple things. So this is kind of the way that we need to do it. And then we're going to say dot strip. So we're going to strip off any leading or trailing white spaces. Then what we're going to do is we are going to return, and we're going to say answer is answer. We're going to say sources, and this needs to be as a string. So sources is going to be equal to found.sources, like that. And then we're going to say the num underscore context. And then what we'll do is we'll just pass the number. So we're going to say len of found.context. Okay. So that should pretty much be it in terms of this function. Again, what we're doing is we have the search step where we're embedding the query, the thing the user asked essentially, and we are then searching for the results in the vector database. We are running that as a step. We're creating a simple prompt here to say, okay, here's the information, here's the question. We're creating an AI adapter. We're passing that to the inference step with our messages. And then we're just kind of parsing the response and returning it. It's really not too complex, but just because we're doing it with Inngest, I want to explain it a bit more in depth. Okay, now that we have that, we can restart the server again, and we should be able to actually run this inference. So if we go back, we can refresh, okay, and we now know that we have one document that we added. I added it about graphs, right? And actually, let me open the PDF so you can kind of see what it looks like. Something like this, right? Where we have like some problems, leak code problems, just like some basic information because we recommend people do, and there's, a bunch more here, certain questions on leak code during certain days based on our DSA roadmap in dev launch. So what I'm going to ask it is something like, what is the importance of graph? I don't know. We'll come up with something, right? But if I go to functions now, oh, we only have one function. Okay, so let's go back here. My apologies, guys. Let's shut this down. Okay, close that, shut this down. And let's add this function to the list. So what do we call this? Rag query PDF AI, because we need to serve the function. So we got to add it into that list there. Okay, let's rerun the application. And apologies, let's go back. Let's go here, refresh. And now we see another function is appearing. So let's go to query PDF. Let's go to invoke. I think this time we just need to pass top K and questions. Okay, so we're going to say question. And then the question can be like this. Okay, and I'm going to ask it something like, what is the importance of graph problems? And let's see, I don't know if that's going to give us an answer, but let's try it. Okay, so it's running, and we could see that it says, embed and search. It ran that step, and then I could hit LLM answer and finalization, and then it gave us the answer here. It said graph problems are important because they help build comfort with fundamental concepts such as modeling problems as graphs, performing DFS and BFS traversals, and managing state and recursion. They also enhance blah, blah, blah. This is a direct quote out of that PDF that I showed you, and it says that this is the kind of context that it looked at. You can see there's another document that I uploaded kind of as a test, although it didn't actually use anything from this. It just was pulling that context. And then it pulled it out of graphs. And if we look through the other steps, we can see all of the input, output, everything that was going on, and kind of the importance of that. Cool. Okay, so that worked. We now have the two functions. And to be honest, at this point, the application is pretty much done. we built a RAG query application, but I do want to show you a few other kind of nice features that Inngest has that we can take advantage of, as well as how we can add a custom front end to this. So for the front end, what I'm actually going to do is I'm not going to code it from scratch with you because it's going to take a little bit of time to do that. I'm going to leave a link in the description to all of the code in this video. In that link, you'll see a Streamlit file. It's going to be called Streamlit app. I'm going to write it in 1 second for you, or you'll see it. And you can just copy that and paste it into this project, and it will be a functioning front end for you to use within this application. So let me show you what I mean. I'm going to make a new file. I'm going to call it Streamlit_app.py. Now I'm just going to directly copy this from my other monitor because I wrote it before the video for the demo. Okay, so I'm just going to paste it directly inside of here, and you guys can find it from the link in the description in the GitHub link. Same thing, literally just copy it and paste it inside of here, and I'll quickly step through some of the code in terms of calling our function so you see how that works, and then this will just be a functioning front end, and I'll show you how to run it. So effectively, this is a Streamlit application, really nice UI. You can just build stuff in pure Python. You can see that we, import Inngest here as well. We create an Inngest client. It's really important that we specify the correct app ID and that we don't specify that this is in production, because if it's in production, we need to pass something called an event key, which you can generate on Inngest, which is a little bit more complicated if you're going to deploy this for security reasons. We have the ability to save and upload a PDF, so we store it and we can upload it. And then we have things like send the RAG ingest event. So like I was saying, if you want to actually trigger one of the functions to run on Inngest, all you have to do is get the client, and then you just send an event. So we send the event, which is RAG ingest PDF, just like we were kind of doing from the UI. We pass the PDF path and the source ID, and that's it. And then it just triggers it, and it runs, and it ingests it, right? Now, same thing for running the query event. When we run the query event, what's going to happen is it's going to return to us the event ID. Now, this is the thing that's a little bit tricky. If you want to get the result from an event, because this is not synchronous, you need to send a different request later. So what I mean by that is the result here is not actually going to be the result of the LLM call. What it's going to be instead is just kind of like some metadata about this event and how it ran. So what I do is I actually just return what's going to end up being here, kind of the event ID. And then we have this code right here, which fetches all of the event runs and then is able to search through this for the most recent event that matches the event ID that we had, and then actually get what the result of that is. Because again, an event might take, a day, a minute, 10 seconds. We don't know how long it's going to take to run. So what we do is we kind of run this loop where we're fetching the events. We're looking for this particular event ID, right? So we're looking for that event ID and then any of the runs. We're getting the most recent run. We're checking its status. If the status is completed, succeeded, success, finished, one of these things, then what we're going to do is we are going to return what the output of that is. Otherwise, if it's failed or canceled, we're going to raise an error. And if we go past the timeout, then we're going to say that there was a timeout. Then we're going to sleep in between. We're essentially polling the endpoint to get the result. This is all documented extensively in the documentation for Inngest, but essentially we just send a request to this endpoint. So we get the API base URL, we send to /events/event ID/runs, and then we're good to go. And this is what the base URL will be, right? Either in the environment variable or 8288/v1/ and then this. Okay. Hopefully that makes sense. Again, I'm not going to explain the entire front end, but I just want to show you that, we wrote it, we can use it. So if we go into another terminal, we can type uv run, streamlit run, and then the name of this, which is streamlit app.py. When we do that, it should open it up for us in the browser. From here, we can just use this UI, right? So I can ask a question like why, or let's go this, why are graphs important? We can say, okay, we just want to retrieve maybe 3 chunks. We can ask that. It's then going to send the event and generate the answer. If we go to Inngest, we can see we have a running event right now, right? Because we sent that from the front end. And then it's going to take a second because of the polling, how we have it set up on a little bit of a delay, and we should get the result. Okay, so you can see we get the answer, and it tells us kind of the, the sources that it used to get that. Now, if we upload a file, let me do this. Okay, so I just uploaded a resume here. This is actually one of our DevLaunch students' resumes, and we did that. You can see it says triggered ingestion, and if we go back here, this event just ran. It's very fast, ingest PDF, and we can go through and we can kind of see what happened here. I don't want to expose this because it has some personal data in it, but the point is, you get the idea. We embedded, inserted, etc. In this case, it was just one chunk. Okay, so that's that. That's the front end, and that's almost everything. The last thing that I will quickly go through is a few things that you can add to the functions for rate limiting and throttling and some more control. So you can do a lot with this, right? I kind of barely scratched the surface of what's possible with this orchestration tool, but I want to quickly show you that a nice benefit of this is how easy it is to add like rate limiting. So for example, if we go to, like overview here, you can see that if we want to add throttling, we can just go throttle is ingest.throttle. We can say, count is 2, period, datetime.time delta. We could literally just like copy this, right? Go back to PyCharm. Let's add this in. And now we have throttling automatically applied to this function, right? Boom, it's there, it's gonna work. Same thing if I go back here. So I could go to flow control here. I could implement concurrency, right? So you can see we can actually have just concurrency directly inside of here. We could add rate limiting. So for example, let me just copy one of these. Okay, so we'll just copy that and paste it inside of here. And you can see now that like I've just added rate limiting. And for the rate limiting, you're also able to add a key. So for something like ingesting the PDF, we may want to have a key that's actually relative to the source ID or something. So we can say key source ID. So now we're only going to apply that based on this key. And there's just all kinds of other things that you can add here to each of the functions. And we would just shut the application down, rerun it. And now all of a sudden we have a rate limit. This would mean we can only run this one time every 4 hours for a given PDF document. That's it. That's kind of how this works to make sure that you're not abusing the functions. There's a lot of other stuff. Again, I'm not going to go through everything. We have priority, debouncing, singleton pattern, concurrency, all of that kind of stuff, which is really interesting and makes this a very powerful tool. Okay, so with that said, guys, that is going to wrap up this video. I think this is a really cool application. It goes above and beyond the kind of basic, simple RAG apps where we just do something locally. This is actually something that we now could deploy to production. In order to do that, I would suggest following along with the Inngest documentation. They have some steps on deployment and essentially how you kind of configure security in different applications and how you set up the environments. It's not something that I have enough time to cover in this video, but if you guys do want a video on it, then definitely let me know and I can likely team up with Inngest again to get that done. Anyways, that is it. I hope you guys enjoyed the video. If you did, make sure to leave a like, subscribe to the channel, and I will see you in the next one.